Okay, in section 3.5, we'll be talking about fundamental theorem of algebra, and we will continue finding the zeros of a function. Okay, and in this section we will see complex zero. So we did one example yesterday, and we did had a complex zero, right? So okay, was that from our homework? We had a complex zero. So this is, yes, so here, so this was so this is the function that we did from your homework, and when we find the zeros of this function, we had a real zeros. It means we had a real number as a zero of a function. Okay, so we had -3 and 1/4. These are the real number, and these are the zeros for the function. So these are the real zeros, and we also had positive I and negative I as a zero for the function, and these two are the complex numbers. So these are the complex zero. Okay, it means when you substitute I, okay, for every x in this function, our output is 0. Okay, so in 3.5 we'll be doing more examples similar to this one. Okay, before that, let's go through one of the basic fundamental theorem of the algebra. Okay, so if we have a non-constant polynomial function with a complex coefficients, you have a polynomial function which is not a constant. Okay, constant polynomial function is like, for example, if we have a function f of x equals to 2, this is a constant polynomial function. Okay, but here we are talking about a function which is not a constant, and that function has at least one complex coefficient. It means the coefficient of the variable is a complex number. If that is the case, then we can always find at least one complex zero. So you have a function which is non-constant, and the coefficient of that function, at least one coefficient of the function, is a complex number. If that is the case, then we can always find at least one complex zero. It means we can always find one complex number whose output is equals to 0. Okay, that's the fundamental theorem here. Now, I don't want to go through this. So let me start with the example here. Okay, then we'll see what it. We did define the multiplicity, and we will see that in this example here. So we have this function h of x equals to x cubed plus 2x squared plus x. So we have the function h of x equals to x cubed plus 2x squared plus x, and our target is finding the multiplicity and finding the zero here. Okay, so we are asked to find the multiplicity here. Now, how do we find the multiplicity? Now, before that, what is multiplicity? Multiplicity is the number of times of factor repeats. Okay, so you have a function. If you have a function in a factor form, we want to know how many times that factor repeats, and that number of times of factor repeats in a function is the multiplicity. Now, our function is h of x. Now, at first, do we have a factor? Is our function in a factor form? So we don't have a function in a factor form. To find the multiplicity, we need to have a function in a factor form. So let's factorize this function. Okay, so the very first step of factorization is we look for the term, we look for the common term in each term. We look for the common factor in each term. Now, in these three terms, do we have a common factor? So in these three terms, what is the common factor? X, right? So let's factor out x. So let's factor out x. So if we factor out x from x cubed, what do we have? What is left? So if you factor out x from x cubed, what is left? We have x cubed divided by the common factor x squared, right? So similarly, if you factor out x from 2x squared, we have 2x squared divided by x, that is positive 2x. And if you factor out x from x, we have positive 1. Now, is it completely factored? Is there any way we could factorize the second factor? This is a quadratic form, okay, and we can always factorize with quadratic form. So we have x plus let's say if we can use a FOIL method here. Okay, if we use a FOIL method, we're gonna have x as a first term, right? Now can you tell me two number whose product is 1 and sum is 2? 1 and 1, positive 1 and positive 1. And we can rewrite this as a x time x plus 1 time x plus 1 is x plus 1 squared. Okay. Now let's find the 0 for this function and multiplicity. Now what does it mean by finding a 0 of this function? So we want to know x such that our output is 0. Now for what x value, okay, for what x value our output, this expression is a 0. 0 and negative 1. Now here if you choose 0 for x, okay, if you choose 0 for x, you have a 0 times 0 plus 1 is square. 0 times any number is 0. So 0 is one real 0. Okay, so 0. And how many times this, so our 0, so 0 is a 0. Okay, so here, so this 0 is a 0 for this function. Okay, now how many times this factor x is repeated? It means what is the exponent of this factor? 1, right? So 1 is the multiplicity. Okay, similarly, at what, for what x value this factor is 0? For what x value this factor is 0? When we choose x equals to negative 1, this factor is 0. So negative 1 is the another 0 and its exponent is 2. Its exponent is 2 and this 2 is the multiplicity. Okay, so we have the 1 multiplicity when x has a 0 and we have the multiplicity 2 at negative 1. Now what does it mean by having a multiplicity, odd multiplicity and even multiplicity? So what can we tell about the graph at 0? So we have the multiplicity, odd multiplicity at 0. These are the x values, okay? Zeros are the x values. So we have the odd multiplicity at x equals to 0. Now what does it mean in the graph? The graph, does the graph touches the x-axis or crosses the x-axis? It crosses, okay? If the multiplicity is odd, every time graph crosses the x-axis at that point. So graph crosses x-axis if it's odd. Okay, now here we have the even multiplicity at negative 1. So at negative 1 in the x-axis, we know the multiplicity is an even number. It means the graph touches the x-axis. It does not cross at negative 1, but it touches x-axis. Okay, that's what we can tell from the multiplicity. So if you know the multiplicity, we can tell whether the graph crosses x-axis or touches x-axis. Okay, so this is all for this function. So we find the zeros and we find the multiplicities. Okay, and from the multiplicities, we can tell whether the graph crosses the x-axis at 0 or touches the x-axis. Okay, any question here? So this is what we did earlier. Okay, now let's go to the next example. So let's not go to this factorization theorem. We'll start from the example. So we have this example. So using the fact that x equals to negative 2 is a 0 for this function. So we have this function, and for this function x equals to negative 2 is a 0. Okay, so negative 2 is a 0 for this function. Now it tells us to factorize this function. So we need to factorize this function. That's all we need to do with the help of this negative 2 as a 0. Okay, now what does it mean by negative 2 is a 0 for this function? So what kind of information we can get? So what does it mean by negative 2 is a 0 for this function f? We know it does tell that negative 2 is a 0 for this function, but what does that mean for us? Okay, x plus 2 is a factor for this function. Okay, one not is a one factor. We can have a more factor. Okay, that's true. Now what are the information? we know negative 2 is a real 0 for this function, and negative 2 is so from that real 0, x minus real 0, which we get x plus 2, so x plus 2 is a factor for this function. Okay, that's the one thing. Now what is the next thing? So if you know any number is a real 0, every time x minus whatever 0 you have, negative 2, this is a factor. Okay, so we have x plus 2 is a factor. This is a one information. Now what can we tell, what other more information we can get from here? Negative 2 is a real 0. That's right. So negative 2 is the x-intercept. Okay, so negative 2 0, or you can write negative 2 is x-intercept. Okay, what other information? Negative 2 0 is the x-intercept. So if we find output at x equals to negative 2, what will be that output equals to? It's 0, right? So if you find f at negative 2, the output is 0. Okay, now what other information we can find? Any more? So 0 is also a solution for this function. So we have this function. Okay, so we can write, so we can make an equation here. So x cube, or which is f of x, just let me write f. So we have this equation. So if we have a f of x equals to 0, okay, so our f of x is this, x cube plus 2x square plus 7x plus 14. Now this is an equation, right? So this is an equation here. So if we have this equation, then what is x equals to negative 2 for this equation? So if we have this equation, what will be this x equals to negative 2 for this equation? It is a solution for this equation. Okay, so x equals to negative 2 is a solution here. So x equals to negative 2 is a solution. We have two more solution, but this is one solution. See, from one information we can get like 1 2 3 4 more information. So if you know any number is a real 0 for a function, okay, then every time, okay, so most important is that x minus that real 0 is a factor. Okay, that's what you need to know. And that real 0, negative 2 0, or that real 0 is a x-intercept. Okay, if you find the output at that x value, at this given x value, output is 0. Okay, and what do we also call this expression from our remainder theorem? Can anyone tell me what is this expression also called? I know this is the output at negative 2, and what is this f of negative 2 also called? Is the remainder that we get when we divide f of x by this factor x plus 2. Okay, so this is also remainder we get after dividing. So dividing, okay, our function f of x, dividing f of x by the factor which is x plus 2. Okay, and if the remainder is 0, and that is the reason why we call this negative 2 as the real 0. Okay, and the last is that if we have an equation, if we set our f of x equals to 0, if we set f of x equals to 0, we get this equation, and this 0 is also a solution for this equation. Okay, now if you know, okay, so if, okay, let me tell you. So if we know f of 5 is 0, so you have a function f and f of 5 is 0. Now what kind of information we can get, or what is this 5? So if f of 5 is 0, now what is this 5 called? So 5 is the So we know f of 5 is 0. F of 5 is equals to 0. Now what do we call this 5? 5 is the real 0, right? X minus 5 is a factor. Okay, 5 0 is the x-intercept. Okay, next 5 is also solution. Okay, so from one real 0 we can get this information. Okay, so you should know all of these. Okay, now so our target here is factorizing this function. So our target is factorizing this function. Okay, so our target is factorizing this function, and we already know, since negative 2 is the real 0, we already know x plus 2 is one factor. Now how do we find the other factor? Now we use the synthetic division, or we can use the long division. And the reason is that if we have any function, okay, if we have a polynomial function, then we can write our polynomial function as a divisor d of x time the quotient q of x plus remainder r of x, right? And in this case our remainder is a 0, so we can write our polynomial function p of x as the divisor time q of x. Now our polynomial is in a factor form. See, we have a divisor time quotient, so this is in a factor form. So we find the quotient, so we divide this polynomial, so we divide this function by our one of the factor x plus 2, okay, and get the quotient. And you can use any method, synthetic division or long division. Now for synthetic division, our divisor is x plus 2. We compare our divisor with x minus c. If we compare, what is c equals to? Negative 2, right? Now we write down the coefficient of each term of the function. So coefficient of x cube is 1, coefficient of square term is 2, coefficient of x is 7, and constant is 14. And we divide this coefficient by our c, which is negative 2. So in order to divide, we drop first coefficient, right? Then multiply by our c. 1 time negative 2, we get negative 2. We do not change sign. 2 minus 2, that is 0. Now let's multiply this 0 and this negative 2. 0 times negative 2, 0. 7 plus 0, that is 7. 7 times negative 2, that is negative 14. And we have 0 at the end. And what is this 0? 0 is the remainder, right? R of x. The last number is always remainder. Okay, now our function f of x is, divisor is, so what is the divisor? What is the divisor here? Is it negative 2 or x plus 2? X plus 2, okay. So factor is a divisor, x plus 2 is a divisor, okay. Now we want to know what is quotient. We need to know what is quotient. Remainder is 0, so we can exclude this, okay. So we write divisor times quotient. Okay, our quotient is, we're gonna use these numbers, okay. These are the coefficient of the quotient. Before that, we need to know the degree of the quotient. Now how do we find the degree of quotient? It's the 1 less than the degree of function. So our function has a degree 3, and 3 minus 1 is 2. So 2 is the degree. And in order to have a degree 2, what should we have the leading term at? We must have a x square term, right? That should be the first term. So this is our coefficient of x square term. This is the coefficient of x term, and this is a constant. So we have 1x square, or simply we can write x square. 0 times x, that is 0 plus 7. So see, we have a function, and we have a function in a factor form. And we can't factorize x square plus 7. Can we factorize or not? Yes. Now yes, we can factorize, but we're going to have the complex number. Okay, now let's go ahead and factorize x square plus 7. And you can use the quadratic formula to factorize x square plus 7. Okay, or okay, is there any way? Okay, now if you don't wanna use a quadratic formula, okay, let me rewrite this. So we have x plus 2. Now can I rewrite x square plus 7 as a x square minus minus 7. Can I rewrite? Is it same? Okay, so here we have x plus 2 as it is. Now x square is x square, we have negative. Now for negative 7, can I rewrite negative 1 times 7? Okay, now next we have x plus 2 and we have x square, we have negative as it is. Now can I rewrite negative 1 as a I square and 7 as a square of root 7? Is it still same thing? Let's double check. So we have x square, we have x square, we have negative, we have negative. What is I square? I square is a negative 1. And what is the square of square root of 7? It's a 7, right? Okay, so we have x plus 2. Now this is, I can rewrite this as a x square minus, so we have a square as a common, so can I rewrite this as a I times square root of 7 square? Is it still same thing? Okay, now see, I have a difference of square. So if I have a difference of square, how do we factorize? So if we have difference of square, a square minus b square, the factor of difference of square is sum of these two terms times the difference of these two terms are the factor. So our a is x, so this is a, this is b. So we have x plus 2 times a plus b. A is x plus I root 7 times x minus I root 7. So these are the factor. We do have the other way using the quadratic formula. You can use the quadratic formula and factorize x squared plus 7. Okay, so if this is difficult for you, let's use the quadratic formula. Okay,
You can also complete this square.
yeah. Do you want to completing square? That's gonna be a lot. So the first option is always like, yeah, you can always use the quadratic formula. Okay, so our target is factorizing x squared plus 7, right? So quadratic formula is negative b plus minus square root b square minus 4ac divided by 2a. So what is negative, what is b here? B is the coefficient of x, but we don't have x term, so it is a 0. So we have a negative 0 plus or minus 0 square minus 4 times a is 1, c is 20, c is 7, right? Divided by 2 times a is 1. Now let's simplify this. So we can ignore this negative 0. So plus or minus. So we have 4 times 1 times 7, negative 28. Okay, negative 28 divided by 2. Let me know if you have question here. Now, how do we get rid of negative under the square root? So negative 28, so negative 28 is same as negative 1 times positive 28, and negative 1 is I squared times 28 divided by 2. So you replace your negative sign under the radical sign by I square. Okay, now so we have plus or minus square root of I square. How can, so can we rewrite 28 as a 2 square times 7? 2 square is 4, 4 times 7 is 28 divided by 2. Now what can we do for I and 2? They have the exponent 2 and the index is 2. So they come out right from the radical sign. So you can write I and 2 outside the radical sign. So we have plus or minus I times 2. These are outside the radical sign. And 7, the exponent is 1. So it stays under the radical sign divided by 2. Can we cancel 2 here? Yes, because we have I times 2 times 7. We have a product form in the numerator. So you can cancel 2, 2. And from here, we get plus or minus I root 7. So x, so these are the zeros, so x minus I root 7 you take negative, and x plus I root 7 you take the positive, and you get the 2 factor. And we already know the other factor is, the last factor is x plus 2. Okay, so these are the factor for the function f of x. So you can use quadratic formula or you can just factorize in any way. Now for this function, we already know the factor. Can you tell me the zeros for this function? Now what are the real zero? Okay, let's find the real zero for this function. Real zero means, can you tell me a real number which give us output 0? So we have the function, this is the function. Can you give me a value for x such that this function is equals to 0? -2. So -2 is a real number, so this is a real zero. Do we have any other real zero? Now we do have a complex zero. Now can you give me a complex number which make this function equals to 0? So how can we have this factor 0? How can you make this expression equals to 0? What should be x? X should be I times square root of 7, right? So if your x is I square root of 7, you have I square root of 7 minus I square root of 7, that is 0. So this is one complex 0. And for this factor, if you substitute x equals to negative of this number I square root of 7, you get the 0. So these are the complex 0 because these are complex number. Okay, let me know if you have a question, and we'll be doing more examples similar to this one. Okay, so we have other examples as well. Okay, let's go to the next one. Okay, so here we have this example here. Find all zeros of this polynomial function. Now why it does tell us all zeros? It means we have to include both real zero as well as complex zero. Okay, for this function, so we have this function and factor p of x over the complex number, and it is similar to the one that we just did here. So let's find the zeros for this function. Now if we so our function is p of x equals to x cube minus x square minus 3x. In order to find the 0, if we factorize, it's easy to find the 0. Okay, so let's factorize this. The common factor is x, right? In each term we have x as a common factor, so let's factor out x. So we have a x square minus x minus 3. Okay, now can we factorize this expression with a factorization method, or we might need to use our quadratic formula? Can we use a FOIL method? Let's try one more time. So let's use a FOIL method. What should be the first term so that we get x square? X. Now can we find a two number whose product is -3 and sum is -1? No, right? So we want to know the two number whose product is -3 and sum has to be -1. So we can't find, it means we can't use, we have to use the quadratic formula here to factorize this one. Okay, so let's use quadratic formula to factorize this expression. So so we already have one factor here. So in order to use, okay, so we have x square minus x minus 3. So our quadratic formula is -b plus minus square root b square minus 4ac divided by 2a. Okay, now what is -b here? B is the coefficient of x. What is the coefficient of x? -1, right? So we have negative, our b is -1, plus or minus square root, our b is -1, we have a square, minus 4 times, what is a? A is the coefficient of square term, which is 1, times c. C is the constant, which is -3. -3 divided by 2 times a. A is the 1. Okay. Now let's simplify this. So negative times negative 1, positive 1, plus minus is square root. Negative 1 square is positive 1. Negative 4 time 1 time negative 3 is positive 12. Divided by 2 times 1 is 2. So we have 1 plus or minus square root of 13 divided by 2. Now let's take positive. So if you take positive, we have 1 plus root 13 divided by 2. If you take negative, we have 1 minus square root of 13 divided by 2. And the factor is, to write down the factor, you're going to do x minus this number. X minus 1 plus root 13 divided by 2. This is the one factor. Other factor is x minus this number, 1 minus root 13 divided by 2. So we have two factor, and we already know the one factor is x, right? So we already know this is the factor. So we have x here, and this is our p of x. It means we have our p of x in a factor form. So we have a 3 factor here. Now let's find the zeros for this function. Before that, do you have any question here? So you substitute in the quadratic formula, okay, you get 2 number. You always get the 2 number here, like this number. And your factor is always x minus this number. So x minus this is this expression. X minus this is this expression, this factor. Now let's find the zeros for this function. Zeros are, now let's find the x such that this expression is 0. Now how can we have this factor 0? For what x value this factor is 0? For 0, right? So 0 is 1, 0. Now for what x value this expression is 0? Positive of this number, right? So positive of this number is 1 plus root 13 divided by 2. Okay, and for what x value this expression is 0? Negative of positive of this number, because we have negative here, 1 minus root 13 divided by 2. And we already have this real 0 here. Okay, see, I just copied this number here. These and these two are the same here. We already have a real 0. These are the real 0, and x minus these real zeros are the factor. So here, now what kind of zeros are these? Are these the complex 0 or the real 0? All of these are real number, right? So there is no I. So all of these are the real 0. We don't have any complex 0 here. And how many zeros here? We have 3 zeros, right? If zeros is 3, what can we say about the degree of a function? It has to be 3, right? And that's what we have. If you go back here, see, 3 is the degree here. Okay, let me know if you have a question. Okay, next example here. It's the same. So it does tell us to find all zeros. Okay, so we have a function of a degree 4. So we're going to have at least 4 zeros or less 0. Okay, our function is it possible to factorize this function now? So we have x to the power 4 minus 2x cube minus 3x square minus 2x plus 6. We don't know how to factorize this. Is there any way we could factorize? Okay, if we make a, let me look for this easier term. If we make a group of 3 terms and 2 terms, like if we group this term and this term, can we factorize? So in the first 3 term, x square is the common factor, right? Okay, let's try this one if it works. If not, I'll just tell you the other way. So x square is the common factor in the first 3 terms. Okay, so if we factor out x square, we have x square minus 2x minus 3 minus, in the last 2 terms, negative 2 is the common factor. So we have x minus 3. Now, can we factorize this? This is a quadratic form, right? And we know how to factorize using a FOIL method. Let's try if that works. So we have x squared. So we're gonna have a 2 factor. X has to be the first term. Now give me a two number whose product is -3 and sum is -2. Two number whose product is -3 and sum is -2. -3 positive 1, right? Okay, -2 times x minus 3. So we have a 2 expression. So this is the first expression and this is the second expression. Now in these two expressions, do we have any common factor? X minus 3. So this is the common factor. So let's factor out x minus 3. So x minus 3. The remaining is we have x squared times x plus 1 minus 2. Now, is it completely in a factor form? So see, this is not in a factor. We might need to factorize this one. So you distribute, you get the x cube. So let's not use this method. It's gonna, you can still, okay? So if you need in order to factorize, you have to distribute x square, right? Once you distribute, you get the x cube, and you need to just redo the same process, okay? Let's use what we learned in this chapter 3 using the finding the zeros and finding the using the synthetic division, okay? Okay. I can erase very easily here, see, but I don't know whether you can erase what you have written or not, okay? So I'm going to erase this one. And let's find the zeros for this function. And how do we find the zero of this function? Before finding the zero, what do we find? We find we did yesterday. So in order to find the zero, what are the options? Our option is from -infinity to +infinity. Okay, in order to find the zero, it is always easy to find. Is the best way would be finding the rational zero first. Okay, so let's find the rational zero, and out of that rational zero we can find the real zero. Okay, so let's find rational zero. Our rational zero is p over cube. P over cube. And what is p? P is a factor of a, is it a constant or the coefficient of leading term? It's a factor of a constant. So what is constant here? 6. So what let's write down the every factor of 6. So +1, -1, +2, -2, +3, -3, +6, -6. And q is the factor of coefficient of leading term. Our leading term is x to the power 4. And what is its coefficient? 1. And its factor is -1, +1, right? So we have p over cube is, so we have a -1 and +1. If you divide all these number by -1 and +1 one by one, we're gonna get the same numerator, right? So we can write our p over cube is 1, -1, 2, -2, 3, -3, 6, -6. Because we are dividing by +1 and -1, we're gonna get the same numerator. Okay, now out of this rational zero, these are the rational zeros, okay? These are the rational zero. Our target is finding the real zero. Now, for what rational zero, our function is 0. That's what we need to know. Let's try with 1. So we substitute this rational zero 1 by 1 for every x in the function. So if we substitute 1 for every x, we have 1 minus 2, that is -1, -3, that is -4, -2, -6, -6, -12. So 1 is not the real zero. So looks like -1. So let's try -1. So if we try -1, fourth power of -1 is +1. Cube of -1 is -1 times -2. That is +2. 2 plus 1, that is 3. 3 minus x square, 1 square is 3 minus 3, that is 0. Okay, it's not, okay, -1 is not a real zero here. Is it 1? Let's try. Okay, okay, let's try. So we have 1 minus 2 minus 3 minus 2 minus 6. So 1 minus,
With +6,
Oh, okay. I'm sorry. So here plus 6. Now do it. Okay. So -2, -3, -5, -7. Yes, 1 is the real 0. Thank you. So 1 is the, so when we substitute 1 for every x, we get output 0. So 1 is the one real 0. Okay. Now we need to find how many more? 3 more, right? This function have a degree 4, so we're going to have at least 4 0. We already know 1 is the 0. Now let's use synthetic division and write this function in a factor form. So if 1 is a 0, what is the factor? So if 1 is a 0, what is the factor? X minus this number 1 is a factor. So this is one factor. We know one factor. We need to find 3 more factor. Now let's use synthetic division. So we write down the coefficient of each term. Coefficient of x to the power 4 is 1. Coefficient of cube terms is -2. Coefficient of square term is -3. Coefficient of x is -2. Coefficient of, constant is +6. So we are dividing this coefficient by what number? Our real 0, 1, or this c value. So we are dividing by 1. So we drop first coefficient. Okay. One time we multiply with this number. 1 times 1 is 1. Write down below next coefficient. -2 plus 1, that is -1. Multiply with 1. So we get -1. So this is -4. -4 times 1, -4. We have -6. -6 times 1, -6. We have 0. So this is r of x. Okay. Now our function is f of x. So we can rewrite our function f of x as a divisor is x minus 1 time the quotient. Okay, what will be the quotient here? So we need to know the degree of quotient. So degree would be, what is the degree? Degree of a function is 4. What will be the degree of quotient? 4 minus 1, 3. So the degree is 3. In order to have a degree 3, our leading term has to be x cube terms. So this is a coefficient of x cube terms. This is a coefficient of, you go in a descending order, square term. This is a coefficient of x term, and this is the constant. So we have x, 1 time x cube, -1 time x square, -x square, -4 time x, -4x, -6. So we have 2 factor. Now this is not completely in a factor form. So we're gonna factorize. So this is already, we can't factorize this expression, right? But we can factorize this, and we repeat the same process here. Okay. Now let me take the second factor and repeat the same process. Let me take x cube minus x square minus 4x minus 6. Okay. Repeat the same, exactly same process. Let's find the rational 0, p over q. P is 6. Factor of 6 is +1, -1, +2, -2, +3, -3, +6, -6. And cube is factor of coefficient of leading term. X cube is the leading term. So 1 and -1 are the factor. So our p over q is whatever we have in the numerator. So we have 1, -1, 2, -2, 3, -3, 6, -6. You are not required to show all these, okay? Unless you are asked to find the rational 0, you are not required to write it down. If you can do this on your head, yes, you can do. Okay? But you are not required to write it down. Now here, let's find a number. Let's choose a number from here. Okay, and substitute here. And we want a number that make this expression equals to 0. Okay, now let's try with 1. So 1 minus 1, that's 0. Okay, 1 is not working, right? Let's try -1. Okay, -1 cube is -1, -1, that is -2, +2. So 1 is not, okay, both of these are not the real zeros. Let's try 2. So 2 cube is 8, minus 2 square is 4, minus 4 times 2 is 8, minus 6. Okay, this is not the real, so 2 is not the real 0. So I had a 2 and this is -2. So this is not a real 0. Let's try -2. So negative 2 cube is negative 8, negative 2 square is 4, negative 2 times negative 4, that is positive 8, negative 6. Okay, this is not a real, yeah, this is not a 0, so this is not positive 3. Okay, 3 cube is 27, minus 3 square is 9, minus 4 times 3 is 12, minus 6. Okay, 9 minus 12, 20, minus 21, minus 6. Yes, so this is the one that we want. So positive 3 is a real 0. If positive 3 is a real 0, what is the factor corresponding to this real 0? X minus this is a factor. Okay, so we have a 2 is a factor. Now let's use a synthetic division. Okay, now you are dividing this expression. Okay, forget about your original function. So our C is 3, so we have 3, coefficient of x cube is 1, coefficient of square term is negative 1, coefficient of x is negative 4, and constant is negative 6. So you drop this 1 times 3 is 3, negative 1 positive 3, positive 2, 2 times 3 is 6, negative 4 plus 6, that is positive 2, 2 times 3 is 6, 0. So this is our r of x. Now our function, so let me go here, our function f of x is, we already know our first factor is x minus 1. Okay, we're gonna write this one, first factor x minus 1. Our second factor is, which one is the second factor? X minus 3, right? So x minus 3. And the remaining, or the third factor is from here. So from the, this is the quotient here. And how do we write it? So what should be the degree here? Square, it is 3, right? The degree of this expression is 3. So we're gonna have square, this term coefficient, this is x, and the constant. So this is x squared, this is x. We have x squared plus 2 times x, 2x plus 2. We have the quadratic form, and if we have the quadratic form, we try the FOIL method or AC method. Now, do you think we can use the FOIL method here? We need to find a 2 number whose product is 2 and sum is 2. Is there any 2 number whose product is 2 and no, right? So we're going to use quadratic formula. Okay, now let's use quadratic formula for this expression, for this factor. So we have negative b plus minus b square minus 4ac divided by 2a. So we have negative b is 2 plus minus b is 2 square minus 4, a is 1, c is 2 divided by 2 times a is 1. This is negative 2 plus or minus b square, which is 2 square is 4, 4 times 1 is 4, so negative 8 divided by 2. So this is negative 2 plus minus square root of negative 4 divided by 2. Now what kind of number are we going to get here? Complex, right? We have a negative under the radical sign. And what do we do with this negative? How do we get rid of that negative? By replacing by I square. And 4 is 2 square. Do you agree? Okay. Divided by 2. So this is 2 plus minus. Now we can, so each factor has an exponent 2 and index is 2. So cancel, right? So square root is gone. So we have I times 2 divided by 2. Now we can now we can separate this, or you can factor out 2 divided by 2 plus minus I times 2 divided by 2. So here we have 1 plus I, sorry, plus or minus. So let's take positive 1 plus I, let's take negative 1 minus I. So these are the zeros, and what are the factor corresponding to 1 plus I? So these two are the complex 0 for the function. And what is the factor corresponding to this complex 0? X minus, okay, concept is same, okay, x minus this number, x minus 1 plus I. We have a 2 terms, so we have a parenthesis. And the factor corresponding to this 0 is x minus this number. 1 minus I. We have a two terms, so parenthesis. Okay, so we have two factor here, and we already have two factor over here, x minus 1, x minus 3. So our x minus 1, x minus 3, and this is our function f of x in a factor form. So we are able to factorize a function using a synthetic division, rational zero theorem. And are we asked to find, I think once you have this, you can find the real zero easily, right? And we already know real zero. So this is the real, this is a complex zero, this is a complex zero, and our real zero is, so 3 is the real zero, and we have positive 1 is the real zero. Okay, so we had a 2 real zero and 2 complex zero. Okay, yeah, this is all for this section 3.5. So let's do this much for today.